All right, calculus, welcome to the end of section 1.1. You got some graphs here I just want to talk about. What it means to, what it looks like to be increasing, decreasing, and constant. So on this graph here, looks like number 1, or 4 problems 1 through 8. Look at this function. Is f increasing on the interval -8 to 2? These are x values. From -8 to -2. From -8 to -2, it is in fact increasing. Yes. Is f increasing on the interval 2 to 10? Now don't look at the point 210, but from x is 2 to x is 10, it's not increasing. It goes down, then it increases. So not on the entire interval, no. On the second part of the interval, it is, but not an entire part. List the intervals on which f is increasing. So from -8 to -2, it's increasing. So you're going to write increasing on -8 to -2. We always use parentheses here because, technically at -8, -2, it's transitioning from, decreasing to increasing and increasing to decreasing. And then from 0 to 2, union 0 to 2. And then, can you see this over here? Then from the end, from 5 to infinity. It's increasing on those intervals. On which intervals is f decreasing? From -infinity to -8. So decreasing on -infinity to -8. Union -2 to 0. Union 2 to 5. Okay. List the values or value of x at which f has a local maximum. We're going to call that the local max. All right. Technically goes up towards infinity. And both, we're going to say it has local max at x equals 2. Local min would be right there. And since the graph's going up, that is its absolute min too. So local min at x equals -8. Find the, sorry if you guys can see that, I was talking about those earlier. All right, I think you can see that. Local max at x equals 2, local min at x equals -8. The x-intercepts, find the x-intercepts. When does it cross the x-axis? X equals -5, x equals 0, and x equals +5. At x equals -5, 0, and +5. And the y-intercepts, it crosses the y-axis at the origin. Y equals 0. All right. Y equals 0. Obviously, the y-intercept is when x equals 0, so we won't put that. All right. Anyway, that's that first one. That's how that goes. Let's see what else I plan on talking to you about. Like number 10. So on 10, it wants the domain and range and a few other things. So let's take a look at 10 here. So domain and range, it starts there with the x and it ends there with the x. So the domain, and we include both, -pi to pi, because it goes through both. The range, low value -1, high value 1. All right. The intervals of increase, it's increasing from here to here. So increasing on -pi/2 to pi/2. So for increase, decrease, constant, we use parentheses there. Okay, where does it decrease? It decreases on, this one's interesting, from -pi to pi/2. It's going down. -pi to -pi/2. Union, pi/2 to pi. The intervals are constant. It's constant nowhere. Look at 11. You got something that, well, we'll do 11 here in a second. It is constant nowhere. All right, so that's a pretty good one there. All right, you can think about what, pi/2, 1, what type of type of deal do we got going on there? Pi over 2, we're 1. At negative pi over 2, we're negative 1. At 0 over 0, we got a sine, part of a sine curve there. All right, let's talk about 11. I know the lighting here is creating an issue. Okay, we're doing the best we can this quarter. All right, so domain and range. So it starts at negative 3, ends at 3, goes through both. So the domain's negative 3 to 3. The range, smallest y value is negative 1. The highest y value is 2. Negative 1 to 2 goes through both. What do we have here? Increasing on, when's it increasing? So it's only increasing on one interval here. From x is 2 to x is 3. It's increasing on 2 to 3. Where's it decreasing? It's decreasing on the interval when x is negative 1 to x is positive 1. It's decreasing, right? Negative 1 to positive 1. Then it has a few times it's constant. So it's constant on negative 3 to negative 1 union from 1 to 2. It is constant. All right, that's how we handle those graphs there. Let's see if we want to talk about one more on the very last page. Let's look at 13 and 15 on the very last page. And then I say that this says I'll make another little video that this section 1.1 is done. We'll start with section 1.3 on Thursday. Okay. So on 13, local max. Local max. You have a local max at x equals 3. At x equals 3, or I'm sorry, x equals 0. Your local max is at y is 3. Local minimums. So it would be the absolute minimums of the graph. At x equals negative 2 and x equals positive 2, you have a y value of 0. Max and min, that's all about altitude, elevation. That's the y-axis. All right? 15. 15, we have a local max here. We have a local minimum here. It's gonna, well, this is periodic, so we should know. We should make some guesses about overall min and maxes there and how this bad boy is gonna go. Anyway, you have a local max at x equals pi over 2. When x equals pi over 2, you got a y value 1. You have a local min at x is equal to negative pi over 2, y value of negative 1. All right. And I think that I will end it with this video right here. I'm going to put together another little video where I show you how to graph some things, do piecewise functions, do a little bit more with the even, odd, and I think that's it. That will fully complete the 1.1 notes. This is Yak Math Videos signing out.